This video is an overview of how to use IRSA tools to explore cluster membership and make color magnitude diagrams in both the optical and the infrared. There's a lot of astronomy exercises that you can do once you have a list of cluster members. Now that there's so much Gaia data available, there are lots and lots of journal articles that have published lists of cluster members. There's a lot of things that you can explore out there. There's lots of different competing lists of cluster members. But in the context of what I'm doing here, you just need somebody's list of cluster members. You don't have to worry about whether or not you have a list that is the end-all be-all complete list of cluster members. You just need somebody's list of cluster members. I've picked one group set of cluster members, and I've picked and extracted the members for 3 clusters: Pleiades, Praesepe, and NGC 6774. 2 of those clusters, the Pleiades and Praesepe, are often regarded as benchmark clusters because they're relatively close, they're relatively well studied, and they often turn out to be the anchors on which many models are pinned. Many people study the Pleiades and Praesepe, and I just picked that 3rd cluster to basically somewhat arbitrarily give you a spread of ages between Pleiades, Praesepe, and NGC 6774. You can pick other clusters. I'll show you at the very end what I did to get them into the format I'm using here, so you can pick and explore other clusters. I've made those 3 cluster membership lists available here. You just need to go and grab this tar file and unpack it. There are 3 files inside: Pleiades, Praesepe, and NGC 6774.tbl. They're IPAC table format files. They're just plain text, but IPAC table format is somewhat fussy. You have to make sure that you've got the headers right, and you have to make sure that the spacing is right. And again, at the end of this video, I'll show you what I did in order to overcome those issues. It's also explained down here as well. Once you have those files, this is what you want to do. You go to the IRSA homepage and then go to IRSA Viewer. Then if you don't already have an Upload tab, then you pick the Upload tab and then go to the Upload tab and then go and find the files that you just unpacked. I'm going to load Pleiades, so it gives you a preview. Load table, and then go back to the Upload tab, replace that, get Praesepe, load table, and then go back to the Upload tab and get 6774, load table. It's given us an all sky image here just to show that the 3 clusters are in very different places in the sky. So let's change this and let's change what's plotted. Let's bring the Pleiades catalog to the foreground and then go to the gears. For the x-axis, we're going to do BP mag minus RP mag for the x-axis, and then G mag for the y-axis. And then we want to change the chart title to Pleiades. Remember which cluster this is. And then for the x-axis label, we want to do B minus R. And then for the y label, we're going to do G. And we're going to reverse the y-axis to put bright objects at the top. Apply, close. Now we're going to pin chart so we can hold on to that. Let's go to Praesepe and do basically the same thing. We're going to go change what's plotted. Instead of RA, we're going to do BP mag minus RP mag. And for the y-axis, we're going to do G mag. Change the title to Praesepe. X-axis, B minus R. Y is G. And reverse the y-axis. Apply. Close. And then pin. NGC 6774. Change what's plotted. BP mag minus RP mag. And then G mag. NGC 6774. B minus R. G. Reverse. Apply. Close. Pin. Going to the Pinned Charts tab, we now have 3 different color magnitude diagrams. You can see that they're pretty different even on this scale. Even when we don't have numbers on the axes, you can see that they're different. You get the Pleiades, Praesepe, where you're starting to get giants pulling off, and then NGC 6774 with more giants being pulled off. So right away, you've got some astrophysics to do here. You can put them in relative age order relatively straightforwardly, and you can start identifying giants. You can start identifying white dwarfs. And moreover, if you want to check and see that you've done that assessment correctly, if you click in that plot, and if you can't remember which data table goes with this plot, click on this icon and it will bring that table to the foreground. And then that source is this row. We can go here, go to and search Sinbad. It's a white dwarf. Not really surprising that that's a white dwarf, but it is. So you can use this to explore more about the sources you can identify in these images. You can see if you can identify any journal articles that study the white dwarfs in Prizepi or in NGC 6774. Now the next step would be, now that you've started to explore the optical color magnitude diagrams, let's go explore some infrared color magnitude diagrams. So in order to grab the infrared catalogs, we need to go to the Catalogs tab and then pick 2MAS. But instead of cone, we're going to do multi-object and then go find any of the files that we have loaded. And then instead of a 10 arcsecond radius, we'll do a 2 arcsecond radius and then search. So here's a list of matches to the sources from the Pleiades. So if we go back to active chart, then we want to go to the gears, and then instead of RA, because all of the columns that are here are all of the columns we had in the original catalog, and then the 2MAS ones are concatenated at the end. So J_M, H_M, and K_M is what we want. So instead of RA for the x-axis, we want to do H_M minus K_M. And then for the y-axis, we want a J_M. And then for the chart title, Pleiades. For the X label, H minus K. For the Y label, J, and reverse, apply, close. So now we have a near infrared diagram. We definitely have an outlier though. I bet if we click on that, I bet we'll find that there's a non-detection somewhere in there. Maybe not. Oh, but it's 3 arcseconds away. Okay, so let's filter this down so that we just have the sources we believe. Filter that down. So now we have a near infrared color magnitude diagram. So if we pin this one, we can look at it next to some of the optical color magnitude diagrams. So there's some things that make it look similar, but it's definitely not the same as the optical color magnitude diagrams. We can also go and grab in the same way the WISE photometry. And if we do a color magnitude diagram from WISE, does it look the same? You should go find out. If we do a color magnitude diagram using WISE data, how does it look different than the optical or near infrared color magnitude diagram, and why? There's a lot to explore there. There's a lot of astrophysics to explore. There's a lot of interesting science that you can do. You can follow the white dwarfs through these plots, or the giants, or the main sequence stars through these plots. So the text that's here talks a little bit more about these things. If you want to read more about what the authors did to get the members for the list that I'm using, the papers that I used are right here. They describe what their membership selection was, how they selected the members that they published as being members of these clusters. And they, in fact, published a massive catalog that has lists of all sorts of members for many, many, many different clusters. And there's lots of ways that you can expand this basic idea to many more different clusters. You can use different or additional clusters. You can distribute the clusters among many different teams of students in your class. You can have many different groups, put them in the correct relative age order based on the Gaia color magnitude diagrams. You can expand to younger clusters. The clusters that I picked are relatively old, so not very many of them will have infrared excesses. If you expand this to include WISE data, there's going to be more interesting things in those color magnitude diagrams. You can expand this to use different people's membership lists, because what one group says are all members of the Pleiades is not, it turns out, going to be exactly the same as somebody else's member list of the Pleiades. There's going to be differences, and that's another interesting avenue to explore. These people publish the proper motions as part of their analysis, and sometimes they even publish the true space motions of the clusters, because that's what they're figuring out when they decide which stars are members. So that's yet another avenue to explore. You can start plotting out the proper motions and true space motions in the galaxy of these stars. The cluster members ought to all be moving in the same direction. You can explore binaries in these clusters, because you can go and pull the light curves for these stars from either ZTF or TESS or Assassin to see if they're eclipsing binaries, because you can identify the binaries from the color magnitude diagrams. So there's lots of interesting things that you can explore based just on the plots that I made here. So if you go to get the data that I started from here, you can go and get their entire data table, and you can get it in several different formats, including a massive FITS table. So if you want to go and grab those FITS tables, you can go to the upload tab here, and this upload feature will read in those FITS tables. So that you can upload the FITS table, then turn around and filter, because when you have it read in, you have a massive table loaded in here. Then you can use the filtering capabilities of this tool to filter it down to just have one cluster. Then you can turn around and save it. You can save the table as displayed in any of a variety of formats. If you want to then turn around and export it so you can use it in Excel, you can save it as a CSV file. Or if you want to turn around and save it so it can be uploaded again into IRSA services, you should save it as an IPAC table file format. The important thing is that once you get it filtered down to have just one cluster and you load it back into IRSA Viewer, then you can start matching it with the catalogs that we have here at IRSA. Then you can start making some of these color magnitude and even color diagrams. There's lots of astrophysics that you can do with the color magnitude diagrams and color diagrams with clusters using the plots in IRSA tools.